Alright, welcome back. Now in this particular tutorial, we're going to have a hands-on of the basics of NLP, right? Some of the concepts that we learned earlier on, right? The likes of word, token, vocabulary, sentence, document, corpus, and all those. So we're going to have a hands-on of some of the words, right? And then in the next tutorial, I'll also introduce you to the rest of them. Okay, so we're going to start first with tokenization. Okay, so we got to understand that tokenization is nothing but the individual words where we chop them into pieces like this. Okay, so let's see how we do it in, we use Python to do that, right, in natural language processing context. All right, so let's get started. So there are different ways to do tokenization in natural language processing, and I'm going to introduce you to them over here, right? I'm going to introduce you to the different ways that we do tokenization. All right, so first, let's start by having a test over here, which we can use. Okay, so this is the test that I introduced you to early on, right? This test that you see here is what I have put over here. Okay, it's just the same thing. This is, Steve Jobs' speech, right? In Think Different. Okay, Think Different, when he was doing the Apple commercial. All right, so that's the test that we have over here, and we're going to base on that test to do the tokenization. Okay, so the first one is just using the dot split over there to do it. Okay, that's just a simple way to do tokenization. Okay, so over here you see that I have stored everything in a variable called test. Okay, all the tests I've stored it in a variable called test. So here I'm using test.split. Okay, and when I don't put anything in the bracket, it means that it's going to split it based on the spaces. Okay, based on the spaces in between them. Right, you can also explicitly specify that it should split on the space by doing this. Okay, but it's not necessary to do that if you don't want to. If you're not splitting it based on anything but just the space, you can just do dot split, and once you do that, it's going to split everything for you. So let me run this test. All right, okay, good. Then when I do test.split, right, when I do test.split, you can see that all the words have been split over here. So the first word, which is here, right, it's becoming individual, right, and then two is also there, right. You can see two has been split, right, there follows by that, right, crazy, right, once, and so on and so forth. Okay, so you can see that all the words have been chunked into individual words for us, so we can call them token. Okay, so this is what we refer to as token. Okay, so who is a token? Is a token, crazy is a token, enough is a token, two is a token, think is a token, that is a token, right? All these are tokens. Okay, all these are tokens over here, right? Now you can split it into individual sentences. Okay, so one sentence will start maybe from here all the way to where full stop is. It becomes a sentence. Okay, this becomes a sentence. Another sentence will start from where this full stop ends all the way to you see another full stop. Okay, so you can chop them into sentences as well. And in that case, it means that you're going to split it based on the full stop. Okay, so if you want to split it based on the full stop, then you need to specify that in the in the argument. Okay, so let me comment this one out. Okay, now this time if I run it, you see how it is. It's just split it based on the sentence. So one sentence all the way from here to all the way from here to the host. Okay, I think to troublemakers or to hosts. Let's see. Let's go and see where it ends. All right, here's to the crazy ones, the misfits, the rebels, the troublemakers, the round pegs in the square holes. Okay, so up to holes becomes one, right? Because these comments were already there. Okay, they were already there. And then the next one will start from there, right? The ones, something, all the way to rules. Let's go and see, right? So let's see. It starts from here. Okay, so the ones, who, something, all the way to rules. That becomes one. Okay, so this one is also one sentence. It has split it for us. And the next sentence starts with you can quote them, right? You can quote them, blah, 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 blah. All the way to, where does it end? Where does it end? It ends here, right? All the way to change things. Okay, so you can quote them all the way to change things. Let's see, right? You can quote them all the way to, all the way to change things. You see that. Okay, and then the last sentence will start from they, right, they push the human race forward all the way to the ones who do. Okay, so that's what it is. They push the human race forward, blah 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 blah, all the way to the ones who do. Okay, so you can base on what you want to do, but mainly we actually split these things based on the spaces between them, right? Like individual words or individual tokens like this. That's what we do. Okay, that's what we do. So that's how you do tokenization just using the split function. All right. Now there are more robust NLP libraries that we use for tokenization. Okay, one of them is what is referred to as NLTK. Right, NLTK, which stands for Natural Language Toolkit. There are a lot of things in this toolkit that we're going to use in our natural language journey. In fact, mainly in the things that you're going to do in the industry, you're going to use NLTK. Okay, you're going to use NLTK. So, previously we have seen TensorFlows and the likes of sklearn and all others, right? But in natural language processing, you will see more of NLTK and another one which we call SpaCy, which we will see in this notebook. Okay. All right. So what we do when it regards to NLTK is that we have a module called tokenize, okay, which has one function called word_tokenize. Okay. That is what you use in doing this kind of tokenization. All right. Let's see how that works. And mainly that's what we're going to use. That's what you're going to use in the industry or any project that you're going to do. Okay. So in order to access NLTK, you have to install it. If you don't have it already, you can easily run this code and it's going to install it for you, right? In my case, I have it, so you see that it's requirement already satisfied. All right, but if you don't have it, then you need to run that code to install it. All right, so once you do that, then you import it. Okay, import NLTK, and then you download PUNKT, which is nothing but punctuation kit, but we will see this later on. All right, you just have to download that. All right, and then you do from NLTK.tokenize import word tokenize. Okay, that's what I was talking about over here. So that's the function that you need to use in order to do tokenization. Okay, once you import that, the only thing that you have to do is to just use it. So you do word tokenize, and then you pass in your text, and that's it. You're done. Okay, that's it. You're done. So once you do that, we have let me just run it, and then you will see. Okay, you see that it's tokenizing everything for you, right? It's just, here is when it was downloading it. All right, and then you see that it's tokenizing everything for you, right? One thing about this about this word tokenizer is that it also takes care of punctuations. So if you see the first one, what split date, right? Let me just run it again. Okay, so split, you see that here is one, it's considered that as one word. But when you consider, when you use tokenizer, NLTK, you see that it's taken here as one word, the apostrophe as one word, the S as one word. Okay, so that's one thing that you need to note. So depending on your use case, right, if you want to consider here is as one word, then you need to use that split over there. But if you want to also split the apostrophe and S out, then you need to use the more robust libraries like NLTK. All right. Okay. So this is for word. Okay. You see that's word tokenize. But if you want to do sentence tokenize, we also have sent tokenize. Okay. So let me uncomment this one out. All right. We have sentence tokenize. Okay. So if you want to tokenize sentence, like I showed you over here, right? So for split, you indicated that you want to tokenize based on the dot. But in NLTK, we have sent tokenize, okay? And sent tokenize will tokenize it based on the, based on the sentence. So let me comment this one out, and then I'm going to run this one, which is the sent tokenize, okay? So let me run that one. Okay, so now see that it's tokenizing based on the sentence. Here is to the crazy ones, the misfit, the rebels, the troublemakers, right? The round pegs and the square holes. That's one sentence. And then it goes to the second sentence, the next, and the next. Okay, so we have 4 sentences in there. So it's going to, tokenize based on the sentence respectively for you. All right. Okay, so that is tokenization using NLTK. Then we have tokenization using SpaCy. Okay, SpaCy, which is nothing but Python and then Python. Okay, so we also have Python. You can just read about that. But I mean, basically, SpaCy is, written in Python in combination with Python. All right, and that's what we use in. That's another library, another robust library that we use when it comes to tokenizing text. Okay, let's see how that works. Okay, now the good thing about SpaCy is that if you want to do tokenization apart from things in English, okay, NLTK will work very, very well when the text that you're going to work on is in English. Okay, but if it's not in English and it's in any other text, then SpaCy will come in handy. Okay, so I have translated the speech that we were using earlier on, which is in English, right? I've translated that to Spanish. Okay, I've translated that to Spanish over here, right? So that's what you see over here. That's what we're going to use. So in SpaCy, right? So from spacy.lang.es, right? So import Spanish, right? Import Spanish. And then once you do that, you just initialize it over here. You can just give it any name that you want. All right. And then, so in this case, that is just not in English, for instance, it's very useful to use SpaCy instead of NLTK. All right. And here is it. Here's the test. And here you can see that I'm using the NLP, which is nothing but the SpaCy, right? Let me even call it SpaCy so that you get to see that. That's what I'm using. All right. Or maybe because we have internal SpaCy over here. So in order not to conflict, I'm just going to make it speak, right? Something like that. Okay. So let's now run it and you'll see how it's going to work. I hope I've changed everything possible. Yeah. So let's run it and you see. Okay, see that it has done everything here nicely for us. Okay, it has done everything nicely for it. Has junked all the words. Okay, you can just copy them. Let me just copy them and then paste all of them here so that you see how it has junked them. Okay, so this is how it is. Okay, so you see that all the words, right? POR is on its own, while LOS is on its own, LOCOS is on its own, the dot is even on its own, loss is on its own, right? So it's going to junk all of them like this for us. Okay, and that's what we want. That's what we want. So since we have Spanish built into SpaCy, it's going to understand the language and be able to junk it for us. Because if you use NLTK, which doesn't understand Spanish, it's going to come up with, it's going to junk it, but that is going to give you a false tokenization over there. So in that case, it's quite useful to use SpaCy. All right. Okay, so we also have Gensim, right? Gensim is generate similar. Okay, that's another library that you can use, right? Gensim is another library that you can use when it comes to tokenizing words. All right, so let's see how that also works, right? So let me get rid of that. Okay. All right, so in order to use Gensim, you use from gensim.utils import tokenize. Okay, from gensim.utils import tokenize, and that's it. Once you do that, you can use tokenize to then you input your text in and you're done. Okay, here I'm just converting it to a list and printing it out. All right, so let me run that and you see that it's giving us the same things. And this one is very critical on very strict on punctuations, right? So you can see that it's instead of here and then apostrophe s, right, it's taking off the apostrophe completely, right? So here and then the is, right, and then the two, right? But if you see what NLTK was doing, it split the, this one is test, NLTK here, right? So let's do the one with, let's do this one, the word tokenize, right? It takes NLTK will take care of the apostrophe, right, as one word, right? But if you use Gensim will get rid of the apostrophe totally. So depending on the use case, if you want this kind of an output where you don't need those punctuations, then Gensim will be a good use. But if you need the punctuations and you want them to be separate words, then NLTK will be good use. And if you need the apostrophes or the punctuations and you don't want them to be separated, then split function will be good. All right. Okay, so I hope now you have a better idea of how to do tokenization. All right. Okay, so I urge you to just go through the notebook once and then see, use different words, just play around and see how these things come up, because it's only when you use it that you get to know more about it. All right. If you want to see all the languages that you can use when it comes to SpaCy, right, you can go to this link that I've given you over here, right? If you click on that, it will take you to the SpaCy documentation, and here you see that we have all the languages over there, right? All the languages that you can use there over here. Okay, so you can just do it that way. And then we've talked about this. So next we're going to talk about stopwords. All right.